All right, welcome to part 2 of the definitive talk on endogenous retroviruses, the so-called best evidence for common descent. In part 2, I am going to go over the superior model in explaining the existence of not only ERV and ERV-like sequences, but retroviruses in general. And I am very excited to have you guys see the evidence that powerfully confirms biblical creation. And let's get right into it. We have a lot to cover here in part 2 of our series addressing very comprehensively endogenous retroviruses. Really quick, we will go through a recap our previous talk. I will make sure that part 1 is linked in the description box of this video. Please, if you have not yet seen part 1, it is thorough. It covers the topic of endogenous retroviruses and retroviruses in general in great detail. I go over all the numerous incredible functional and operational roles associated with ERV and ERV-like sequences. I am not going to be going through all of those functions and all those details again in part 2. I have one specific major point that I want to cover in this specific video, and that is the superior model. A quick recap here. Why are ERV-like sequences shared between the genomes of organisms? Well, in part 1, I asked the very important question, are endogenous retroviruses really the ancient remnants of past viral infections, or are they created units of DNA function? I demonstrated sufficiently that yes, ERVs are mostly created units of DNA function. I went over the many amazing roles associated with ERVs and ERV-like sequences. Those include embryological development. They act as antiviral protectors functioning in the immune system. They function in viral mimicry. They function in gene expression. They function in determining cell types. They function in gene regulation. Function after function after function associated with endogenous retroviruses. As a matter of fact, functions for all classes of retrotransposons. It is a great time to be a biblical creationist, guys. And all of this is supported and backed up by the conventional literature. If you watch part 1, I backed up every single point that I made directly from the conventional literature, going through paper after paper. So do check that out. So the question, why are ERV-like sequences shared between the genomes of organisms? It is common design, because if the majority of ERVs, and I say ERV-like because the majority of so-called ERVs actually represent solo LTRs. We understand, based on the evidence, that solo LTRs are simply stretches, functional stretches of DNA. They function in acting as binding sites for enhancing or initiating gene expression. And the evolutionary community will typically leave out the bigger picture. The fact that over 90% of so-called ERVs may not even be ERVs, just simply functional stretches of DNA. And therefore, the answer to the first question is common design. It's the same reason why all modes of transportation have engines in common. It's important. It's good design. If viral-like sequences in the genomes of organisms are functional, which we've demonstrated sufficiently that they are, there have been comments. I'll do a comments on comments video, but the comments that have come in over the first talk asserting a lot of assertions not backed up by evidence, but the assertions that say, well, it's only a very tiny fraction of overall ERVs that are functional. Some have said 1%. That is an assertion. Whoever taught you that, they lied to you. You need to get your money back. Okay. And we'll do a whole video, comments on comments, showing why these rescue devices simply don't work. And the so-called challenges and objections are unimpressive, underwhelming. Why do they bear similarity to viral genetic material? So in other words, why do ERVs share sequence similarity to retroviruses if they did not originate from retroviruses? That is all of the ERVs. Well, the answer to that question was answered thoroughly in part one. The answer is that their sequence similarity, their makeup, the way that they're designed, LTR, GAG, pol, ENV, the ENV component is the envelope protein, and LTR. Okay. The design of an ERV is necessary to carry out many of their functional roles, one of them being viral mimicry, and also their role in fighting off harmful viruses and acting as antiviral protectors and units in the genomes of living organisms. Every single aspect of the ERV is active in those functions. And so if they did not look like retroviruses, they would not be able to carry out those functions. We will also see in the superior model that if retroviruses originated from pre-existing designed, functional, and created retroelements and retrotransposons, then of course retroviruses are going to look very similar to that which they originated from. And we'll get into that. I'm excited for that aspect of this talk. What is the best explanation for the nested hierarchical distribution of endogenous retroviral-like sequences in primate genomes? If the majority of ERV and ERV-like sequences are created units of DNA function, they represent designed elements in the genomes of biological organisms, then of course we are going to share more of them with a chimpanzee than we do with a dog. Okay, because we look a lot more similar to a chimpanzee than we do to a dog. Human engineers design in nested hierarchical patterns. And what do we find in the created order? We find that God created hierarchically. This is good design. This is reflective of design, hierarchies by design, rather than descent. This is just a real quick recap, as part one touched on this again in great detail. And so the answer, reflective of design. Last question, can separate ancestry explain the data better than common descent? The answer to that question is yes. A superior model. Okay, firstly, guys, remember that ERVs are part of a family of retro elements. We went over this in part one of this talk. And what retro elements are, they are sequences that can move around the genome of the host by what's called reverse transcription. That's simply transcription in reverse. You'll know transcription as being DNA transcribed into RNA translated into protein. And so transcription in reverse is RNA to DNA, because retroviruses, their genetic material is RNA. They have an RNA genome that needs to be reverse transcribed into DNA, and that is done through an important enzyme called reverse transcriptase. And there's another important enzyme that allows a retrovirus to integrate into a host genome, and that would be integrase. Okay. Now, some of these retrotransposons are ERVs, endogenous retroviruses, and others are not. But ERVs are a specific type or class of retro elements. Now, what's interesting is many in the evolutionary community, and you can see this in your most recent lectures on viruses, that includes retroviruses, from evolutionary virologists. They are now admitting the reality, okay, that retroviruses have originated from pre-existing retro elements. In other words, retro elements predate retroviruses. This point is going to be important in a minute, okay? And so notice on the slide here, a superior model. Host genomes must have existed prior to retroviruses because retroviruses require a host to replicate. So this is the important chicken and egg problem for the evolutionists. Since a retrovirus requires a host to replicate, what came first, the host or the retrovirus? The retrovirus requires a host to replicate. And so if the retrovirus came first, then how can the retrovirus replicate and therefore spread? So the host has to come first, which is why retro elements or retrotransposons would predate retroviruses, because retroviruses came from pre-existing host cells and pre-existing host genetic elements like retroelements. And so on the slide, to the evolutionists, what came first, the retrovirus or the host? Harmful viruses have originated from pre-existing created retrotransposons. If this is the case, which the evidence overwhelmingly suggests it is, then as a result, the ripple effect of this answers the great majority of challenges and objections offered and presented by those in the evolutionary community, those that are critics and skeptics of biblical creation and separate ancestry. It also adds another level to answering the question, why do ERVs look like retroviruses? Why do they share sequence similarity with retroviruses? Well, if retroviruses came from retroelements, of course, they are going to look very similar to that which they have originated from. Guys, this is incredible. This data is truly fascinating. Okay. And so what many in the evolutionary community, those that study viruses, okay, evolutionary virologists, they will say that retroelements were in the genome prior to the origin or evolution, as they would say, retroviruses. And these would be retroelements specifically. Okay, there's a number of hypotheses on which retroelements and which DNA elements gave rise to retroviruses in general. But one specific type of retroelement would be the type that does not have an envelope gene. That's the ENV component of your ERV and your retrovirus. And so as soon as a retroelement acquired an envelope gene through various means, recombination, errors in the packaging process, okay, then you have a retrovirus. And this can all happen within the genome based on pre-existing DNA units and sequences. This means retroviruses originated from cells that had retroelements. Well, wait a minute. If God front-loaded the original created kinds with various classes of functional retrotransposons that are functional in a number of ways, determining cell types, gene expression, gene regulation, acting as antiviral protectors, embryological development, all the different functional roles that we went over in Talk 1. Well, it makes sense after the fall and after the flood, especially due to shifts, negative shifts and changes in environment, you would have retroviruses, harmful exogenous retroviruses originating from pre-existing created retro elements simply through mutations, errors, recombination, exon shuffling, a number of genetic means or mechanisms can result in this. And the most amazing part is that even those in the evolutionary community are acknowledging this reality because of the question, the important question, what came first? Retroviruses or the hosts? Retroviruses require hosts to replicate. And so, if retroviruses came from retrotransposons, the pre-existing ones, the ones that were created, the ones that are beneficial, healthy, and functional, this actually confirms the creation model that I have been arguing for. Pre-existing designed retrotransposons gave rise to harmful exogenous retroviruses. This provides an elegant explanation to just about every challenge and major objection that those in the evolutionary community and those that are anti-young earth creationist have thrown our way. And so, in other words, guys, functional retrotransposons were created by God in the beginning, as evidenced by their incredible functional roles, many which are irreducibly complex. Show me, evolutionist, a non-functional endogenous retrovirus going from something that is non-functional and harmful to something that is essential for life to exist. For example, mammals require a retrotransposon, an ERV to be specific, for embryological development, as in without them, we would not exist. And so how empirically are you going to show and demonstrate that a non-functional endogenous retrovirus, okay, an exogenous retrovirus integrated in the right way in the right spot, was passed down to progeny, so it infected a germ cell, passed down to progeny, and over time mutations wiped away the harmful aspects or properties of that viral DNA, and eventually through either co-option or beneficial mutation accumulation evolved a function in the embryo and in the placenta. Show me that. Answer that challenge. Because the best explanation is designed because naturalistic evolutionary mechanisms cannot account for several of these major functional roles. Okay. And so, due to mutations, due to errors in the packaging process, due to recombination, most likely after the flood, okay, we get retroviruses. We get harmful exogenous retroviruses. Since the majority of ERVs are also created, the harmful retroviruses we know could have also come from pre-existing designed ERVs. All the necessary components and properties are there for this to happen. And we could make a prediction. We could take exogenous retroviruses today, like let's say HIV, the most common and well-known exogenous retrovirus, and we can track it back through the animal kingdom to where it could have originated from, its original host, because it did not originate in humans. HIV in humans, SIV in chimpanzees, I believe it is. From there, I think you can trace it back to a monkey and possibly to a type of mouse. But the whole point is we should be able to track back these exogenous retroviruses to their original host that they may have jumped from, because when you have an exogenous retrovirus move horizontally from a host that it's not really causing harm to, its original host, you could say, it will cross into another species, and that other species can't regulate that virus, and now it burns hot and fast and causes havoc, causes damage. Okay, here are some important points to consider on the superior model. Fixed versus unfixed ERVs or ERVs. Okay, so the majority of endogenous retroviruses in humans are fixed. They're stuck in place. Every single human being has them. Okay, there is a small portion of those ERVs that are not fixed, where only a specific subset of people have them. Okay, so that would be an example of a true ERV. that resulted from exogenous retroviral infection, and it was passed on vertically because it infected a sperm cell or an egg cell, and it was endogenized. Okay. And so now every single cell in the progeny are going to have that viral DNA. We see an example in koalas where pre-existing functional, I would say created and designed ERVs are actually working to stop the endogenization process, where koalas are being infected by exogenous retroviruses, and the pre-existing ERVs are working to disrupt the endogenization process. Okay. And so there is evidence for forward thinking where pre-existing designed ERVs are working to protect its host. And this is all truly incredible evidence for design. And so, yes, there are unfixed ERVs, and I would predict that those are true ERVs, but they're certainly not going to be ERVs that are functional in, let's say, embryological development. These major functional roles that we see associated with created ERVs. Okay. And so after the flood, you would have exogenous retroviruses. Okay. These rogue DNA elements that originate from host genomes, pre-existing retro elements. And from there, especially before the Babel dispersal, you can have an exogenous retrovirus move horizontally into another species where if it infects a germ cell, it can be passed on and become an actual ERV. But we wouldn't expect those to be fixed. And if it occurs prior to the spreading out at Babel, they could occur at a higher frequency. Okay. But after the Babel dispersal, we have people groups moving to all parts of the globe, seizing dominion over the planet, essentially. Now you're going to have independent mutations accumulating, right? This is where we could look at allele frequencies, common alleles versus rare alleles. How do we know what is the result of design diversity or created heterozygosity? And how do we know what is the result of true mutations? Well, we've discussed here on this channel many times before that we would look to common alleles versus rare alleles. If it's common, beneficial, not disease causing for the most part, then we would predict that is most likely a created allele. If it's rare, if it's only found in a specific subset of people, then it is due to a mutation. An example of that would be blue eyes. Only a specific subset of people have blue eyes. These mutations or alleles that are rare would have occurred after the Babel dispersal, where your common alleles were most likely part of the design diversity. And so, yes, true ERVs can happen, and we can typically know if it's a true ERV if it's unfixed. And again, if an endogenous retrovirus occurs due to exogenous retroviral infection prior to the Babel dispersal, well, since from the flood to the Tower of Babel, you have humans isolated, they haven't spread out yet. Well, you're going to have faster rates of fixation. And so you could have that ERV potentially spread to more people and reach a higher frequency. So if we do see some unfixed ERVs at higher frequencies, well, we can attribute that to an exogenous retroviral infection passed down vertically in the time period between the flood and the Babel dispersal. Okay. And this explains the data that we see. This is why it's so important to understand that we have a bigger picture we need to focus on. What's the bigger picture? What is the origin of exogenous retroviruses in the first place? Okay. Polymorphic ERVs, for example, HERV-K. It's the same thing. If exogenous retroviruses originated from pre-existing retro elements, which the evidence strongly suggests is the case, then that means you can have unfixed ERVs because you'll have true harmful exogenous retroviruses moving horizontally and possibly infecting in the right way, in the right spot where they're passed on. Okay. And that would explain polymorphic ERVs. Not a problem at all. Now remember, if retroviruses are coming from retro elements and even ERVs that have these functional roles, they were created, designed with these functional roles. Okay. Well, that means the retroviruses could take attributes of those retro elements with them. And so if they infect a host, they may actually utilize those attributes, such as acting as antiviral protectors or working in cell stress responses. Okay, because there's been an example provided in, if I remember correctly, in mice, where we have polymorphic ERVs. And I think one of those ERVs, there's an example of them being functional in the immune system, perhaps. And yes, that makes sense. That's why, again, it's so important to answer the bigger picture question. If exogenous retroviruses are originating from host genomes, specifically retro elements, then they could take attributes, including some of those functional roles with them, into other species. If they're in another host, well, retroviruses are selfish. They do want to spread. They don't want the host necessarily to just die. That's why if you have a cold, right, a cold virus, for example, this is just an example. What happens when you have a cold and you're symptomatic? Well, you sneeze. The virus wants to cause symptoms where it can spread throughout the population, so it can flourish and replicate. Okay, so if these exogenous retroviruses are in new hosts, well, due to their selfish nature, they can potentially protect that host from competition, other viruses coming in. But ultimately, they're taking those functions, those pre-existing abilities from the pre-existing functional created retro elements. Okay, and I understand this is complicated, this is technical, but this is where we move from demolishing ERVs as evidence for evolution and again move into the superior model, because it's not only about refuting evidence for evolution, it is about model building. Model building is important. The last point here, post-flood viral infections. If retroviruses originated from pre-existing retro elements, that means you have the potential of having an exogenous retrovirus infecting, and if it infects in the right way, it could be passed on vertically to be a true endogenous retrovirus. But again, there are factors that we can look at to determine, okay, this right here is fixed, it's functional, it's not disease causing, therefore it's created. This over here is unfixed, or it could be unfixed but at a high frequency. Okay, and this is most likely a true ERV. And so there are factors at play that we can look at in order to answer that very important question: what is a created ERV and what is a legit, real endogenous retrovirus from exogenous retroviral infection? And I would say in 99% of the cases, it'll be very easy to figure that out and answer that question. A superior model continued. Host genomes must have existed prior to retroviruses. So in a way, this is recapping what I've just said and went over, because retroviruses require a host to replicate. The evolutionists really need to answer this question, which is why I've repeated it 3 or 4 times. What came first, the retrovirus or the host? Harmful viruses have originated from pre-existing created retrotransposons. This is your best explanation in light of what we know about the nature of retroviruses and viruses in general. ERVs are not vestiges or leftover remnants from ancient RNA retroviral infections. It is the other way around. RNA viruses have originated from the various classes of designed retrotransposons. You might be asking yourself, well, wait a minute. The designed ERVs, one of their functions is acting as antiviral protectors. They're like the antivirus programs in our computers. They are protecting us from harmful viruses. And this is great evidence for forward thinking, which points us back to the forward thinker. Okay. God has that knowledge that Adam and Eve are going to sin, that the fall is going to take place. And so having adaptive mechanisms built in to the genomes of living organisms is good design. In the same way that engineers that build and design cars, they design cars with what? A spare tire. If you had the evolutionist mindset, you'd look at a spare tire on a new car and say, what is this doing here? This is junk. This is useless. What am I going to use an extra tire for? A fifth tire? Okay. But it's good forward thinking, because if you enter an environment with your car where you get a flat tire, well, now you're going to be very thankful that your human engineers thought ahead, okay, through foreknowledge, and they designed the vehicles with a spare tire, with a jack, in order that you can go and change that tire. Okay, this is all good design and evidence of forethought. Now, designed ERVs, they act as antiviral protectors. And in the same way, we have incredibly designed DNA repair enzymes that fix DNA breaks. We can experience in a single cell, in a single day, up to 1 million DNA breaks. 1 million. Thank God we have these amazingly designed DNA repair enzymes that work at fixing a lot of those DNA breaks. But they don't fix every single DNA break, do they? No. We still have mutations that occur in somatic cells. We still have mutations that occur in germ cells, and mutations are passed on. In autosomal nuclear DNA, the mutation rate is anywhere between 100 and 200 new mutations per person per generation. In the Y chromosome, it's between 1 to 3 per generation. In the mitochondrial DNA, somewhere between 0.1 and 0.5 per generation. So mutations do happen, and not all mutations get fixed, because your DNA repair enzymes don't work perfectly. They work well. They work incredibly well, but they don't work perfectly. ERVs, the ones that are created, and we see an example of this in koalas, they work really good. They're really effective at fighting off exogenous retroviral infection, destroying them before they can cause any harm. But do they work perfectly? No. From time to time, you can get a true exogenous retroviral infection in a germ cell, and it can be passed on vertically. Okay. And so let's continue here. Notice this right from the secular literature, guys. This is all backed up, because even virologists in the secular world are understanding this chicken and egg problem, and they are now admitting that, yes, retroviruses may have originated from retroelements. Okay, let's have a look at this. Contemplating the origins of life fascinates both scientists and the general public. Understanding the evolutionary history of viruses may shed some light on this interesting topic. To date, no clear explanation for the origin or origins of viruses exists. Viruses may have arisen from mobile genetic elements that gain the ability to move between cells. Isn't that interesting? What have we learned in our first talk? What did I explain in the introduction of this talk? Well, ERVs are part of a family of retroelements, and retroelements are sequences of DNA that move around the genome. Okay. The function is retrotransposition. Okay. And so those in the conventional literature are admitting that viruses, notice this, viruses might have come from broken pieces of genetic material inside early cells. These pieces were able to escape. This is the escapee hypothesis. That's why I say Retroviruses could be rogue elements. They could have come from pre-existing retro elements, including pre-existing designed ERVs. And once they cross to another species that can't regulate it, now it can burn hot and fast, cause damage, cause havoc, even turn into an endogenous retrovirus if it's passed on vertically. Okay. In this way, they evolved into viruses. And this is just a teaser into all the information you can find in the conventional literature. You can find this in a number of fascinating lectures on retroviruses. A third prevalent hypothesis, the escape hypothesis, suggests that viruses were once part of the genetic material. This had to have been the case. And this makes most sense from the biblical creation starting point. Okay. But escaped cell control and later evolved by pickpocketing genes. So let's say taking an envelope protein. Okay. And now it's a full-fledged retrovirus. Again, this is truly amazing information here. And so I'm going to wrap up here with this example. Part 3, I am going to do just a whole video on junk DNA and just showing why the junk DNA paradigm really has been overturned. The rescue devices don't work. We find these ERVs in the 80% of the genome that's active. This includes the pseudogenes, the evolutionary community, those that are militant enough to want to still hold on to junk DNA. They continue to assert that the 80% activity that we find in the genome is spurious. It's just noise. And there's many reasons why that is not the case. And so if we can demonstrate that the 80% genomic activity, the biochemical activity, is beneficial activity, it's real functional activity, then that demonstrates that your majority of ERVs are functional, even the ones that we may not understand currently exactly what that function is, because we are in the infancy of understanding the DNA language. We are learning more and more and more. That's why you find in these technical papers in the conventional literature discussing the functions of ERVs, they admit right in these papers that our knowledge is increasing more and more every single day about the functional roles associated with ERVs. I predict in 5 years, 8 years, 10 years, we are going to find out more and more the specifics of what each ERV and ERV-like element is doing in the genome. We as creationists, we expect treasure. It is the evolutionary community that expects, unfortunately, junk, which is why evolutionary theory actually hinders science, hinders scientific discovery. They have accidentally discovered functions for various DNA elements that they thought and did not predict would have functions associated with them. That includes pseudogenes, ALU sequences, the various classes of retrotransposons like lines, signs, right? Long interspersed nuclear elements, short interspersed nuclear elements, endogenous retroviruses. They accidentally discovered functions. And so now that we're actually looking for functions, because we're saying to ourselves, hey, maybe these aren't junk after all. Maybe that was a bad assumption. Maybe that was a false assumption. Now we're finding more and more and more functional roles associated with these fascinating DNA elements. It's just like dinosaur soft tissue, the red blood cells, the collagen that is found in these dinosaur fossils and these dinosaur bones, because at first they were accidentally finding these biomaterials that shouldn't be there if they really are millions of years old. Okay, you basically find these preserved organic materials in just about every layer where there's creatures. Truly amazing. And there are, Dr. Brian Thomas had in his presentation at our conference, Science Confirms the Bible conference, he had a list of over 120 papers describing these findings. So it's not just one or two, especially now that they're actually looking. Whereas before, these were accidental findings because of the evolutionary mindset. But when you expect treasure, you're going to find what? Treasure and not junk. So notice here in the visual, this is an example of the separate ancestry model that we hold to. And so you have humans, created humans, okay, and you have non-human great apes, for example. And so you have humans at creation, created by God, with design diversity, front-loaded with various classes of functional DNA elements like ERVs and other retro elements. And then you have the flood. Okay. And after the flood, you don't have the Babel dispersal until many years later. Let's say somewhere between 100 and 350 years later. Okay. From that time period, you have human beings isolated in a smaller population. They've yet to spread out. Okay. So you could have mutations spreading to fixation rapidly. And if you're having exogenous retroviruses due to mutations, recombination, errors in the packaging process, these things, the result of the fall and negative shifts in environment after the flood, you can have true ERVs that go before the spreading out to a higher frequency. Okay. So rather than being unfixed at a low frequency, 5, 6, maybe 10%, if it occurs prior to the Babel dispersal, you may have a true ERV at a higher frequency, but not yet fixed, as in stuck in place at 100% frequency. Okay. And that same thing would apply to other species. Now, when you ask the evolutionist, okay, to provide an answer to the question that I asked earlier, show me an example of an exogenous retrovirus infecting, integrating, being passed on vertically, and evolving or gaining the ability to function in a way that is essential, that without them, we wouldn't survive and wouldn't exist. What you're going to get is a lot of fancy storytelling, a lot of imagination, right? Because evolutionists hope, dream, and imagine that they're related to whales, pine trees, banana plants, walking sticks, and strawberries. Okay. Even though the scientific evidence strongly contradicts that idea, that story. And so you will get a lot of ERV story time from the evolutionists, and you'll know when you hear them assert co-option. Okay. Evolutionists hope, dream, and imagine that this is grandpa based on shared endogenous retroviral-like sequences. But we've proven, we've demonstrated here in our 2 talks that no, ERVs fit best within a creation model. And it is the creation model that has the what? The superior explanation. And the rest of what I have here, I am going to save for talk number 3. But I did want to confirm even further what even non-creationists are now conceding and admitting, which confirms what I've been saying. Why did retroviruses originate from retroelements? Ask AI the right question. Retroviruses are thought to have originated from retroelements, they're not denying it, specifically long terminal repeat retrotransposons through the acquisition of an envelope gene. Okay, so originating from what? Pre-existing genomes, pre-existing functional, and I would argue created for good reason, retrotransposons. Why did retroviruses originate from retroelements? And the same thing, but you can read some of their various hypotheses. While retrotransposons can move within a cell's genome. And what's interesting is they'll point to target site duplications and these various signatures or scars that are left behind when an exogenous retrovirus infects and becomes an ERV. But you get the same signatures and you get the same scars when a pre-existing retrotransposon within the genome that has the ability to move through retrotransposition. When they move from one place in the genome to another, okay, they do this through various means, cut and paste or copy and paste. They leave the same signature. So they would look at these signatures or so-called scars and conclude erroneously external infection when it's actually these scars or signatures are being formed or created internally. Okay, and they have no way to prove otherwise. And so, guys, there's a lot of literature here on this topic and on what I call the superior model. And so, guys, I hope you enjoyed that. I hope this has been edifying. I hope it made a sense to you. I know it's a technical. It is a lot of you might be hearing about this for the first time, but I do plan to put the superior model in writing in my expanded edition. A lot of this is in the first edition, but I plan on expanding in great detail the Endogenous Retrovirus Handbook, and that includes addressing a lot of these criticisms and challenges offered by our critics. Now that I've gotten these two parts done, part 3 will largely focus on debunking junk DNA in general. And I've also been working on a point-by-point rebuttal that I am basically ready to record to a video put out by Dr. Zach Hancock. I do appreciate his interaction, his engagement, and his ability to stay as up to date as possible on this ongoing endogenous retrovirus debate in order for us to have a profitable back and forth discussion on this topic. And so, guys, thanks again for tuning in, and I hope you enjoyed this, and we'll see you all again soon. God bless.